So hello everyone, welcome to our new video, and let's start with our today's video. Today we are going to have a look how we can do the linked list implementation of stack. And before this video I have already recorded two videos on array implementation. The first one was the direct implementation and the second one was reverse implementation. If you have not watched those videos, then I will ask you to watch those videos first and then come back to this video, and I will also give the link of those videos in the description and also on the I button at the top right corner. So please watch those videos and then come back if you have not watched those videos. And now if you have watched the video for the reverse implementation of array, so I said that there is a twist, that why we have to learn the reverse implementation. So why it has actually to be done, because whenever we are dealing with linked list, every time whenever we add any new node, that node has to be added at the very first. But the normal array implementation that we did, it had at the very last. So here we are not going to do it at the last, we are going to do it at the very beginning every time whenever we are adding any new node. So that was the twist. So now let's see how we are going to do the implementation of stack using linked list. So here we have some methods here as push, print, pop, isEmpty and pick. These all methods were also available in the array implementation. Now one method is missing here, that is full. So why it is missing, you will come to know further while you watch the video. Now let's look forward. Now as we have to create a linked list, so a linked list will have various nodes. So here we have a node structure here. Here we have a node structure where we have two parameters. The first one is the data and the second one is a pointer named as next, which will be storing the address of the next node every time. And here we have the top node, which is right now storing a null value, and every time it will be storing the address of the first node itself, which will be also representing the top node. So here if we are creating a linked list, so the top node will be on the left every time and the first node will be on the extreme right at the end of the linked list. So now let's go to the main function. So here we have the same things as we did it previously. We are asking the user for the choice for the different operations that the user wants to perform: push, pop, printing the top element, or printing all the elements of the stack. Then whatever the user gives the choice, depending upon the choice, we have to perform those operations. For the user enters 1, then we are supposed to enter the element to be pushed. We have to ask this from the user, take the value, call the push method and pass the value data. Now how the push method actually works, let's go to the push function here. Now here we have the push function. It takes the data input and then we have to create a node dynamically. So here we are using the malloc function, which takes the size of the structure node and it returns the address of that node. So whatever the address it returns, it is a void type. So here we have to first convert it to the node type, and then we have to store this address into a pointer of the node type. So here we have a pointer of the structure node type as new node. So in the new node it will be storing the pointer here, and every time whenever we are taking the value, every time we have to check if the memory is allocated or not. If the memory is not allocated at any point of time, then it returns a null. So here we have to check new node equal to null. So now why we don't have a is full function in this program? Because here we have to dynamically allocate the memory, and for dynamically allocating the memory, whatever the memory size we have in our system, the entire memory is available to us. so we don't have to think much about this. So there is no fixed size for the memory for the linked list. So here, if it is returning a null, at that point we can give the instruction to the user as the stack is overflow. Okay, and rest every time whenever we create the new node. So the new node, it has two parameters. The first one is the data. So in new node data, we are going to store the data that we obtain from the user, and then in the next parameter, for the very first, for every time, not for the very first, every time whenever we are taking any values, we actually have to store null. Let's suppose if it is the first node, we have to store a null there, right? So here it is written as null. But whenever we create a further new node, so every time in the new node we have to store the address of the top node that we have. So that is why here we have the code as top, because top is also a pointer and it is always storing the address of the first node. Now here, if you see, we have initialized this value as null. Whenever it is empty, so top stores a null value. So anyhow, whatever be the value, it is going to store there. The new node next will be storing either the null value if it is a first element. If not, then it will be storing the address of the previous top node. And then in the top pointer, we have to store the address of the new node that we have just created. This is it about the push function that we have in the linked list implementation of stack. Now let's go to the second option. Here we have the pop function. It returns an integer type of value, and whatever it returns, we are going to store it in the data variable and then give the instruction to the user that the deleted element is whatever it returns from the pop method here. So now let's go to the pop method here. So here we have the pop method. So if the stack is empty, so it is clear that the top will be storing a null value. So here we have the is empty. I will just show you after this. So as of now, if it is empty, then just give an instruction to the user that the stack is underflow. Else, whatever is the topmost value, store it in the value variable so that we can return it later. And then we need to create a temp variable, or you can also create a delete variable. This temp I have just created so that we can release the node whichever gets deleted. So in the temp variable, I am storing the address of the first top element that we have, and every time whenever we want to pop out anything, so the first element of the linked list, the top element, has to be deleted, and the top changes to the next element, the second element. So here, that is the reason why we have to write here as top equal to top arrow next. It will be pointing out at the next one, and whatever we had in the first one, that is its address is stored in the temp variable. Now as it is already deleted, we don't have to use that memory. So now we are going to use the free function and release the address which is stored in the temp variable so that it can be used by some other processes on our system, and after that simply return the value whatever we had in the top arrow data. So done with the pop function. Now this is the is empty. If we check here is empty, so if it is empty, then it is obvious that the top will be equal to null. In that case, return a 1, else return a 0. We have this pick function which returns the topmost element. So again comes the use of the is empty function, because if it is empty, we don't have any element. So what it is going to print? Nothing. We will not have any value. So here printf stack underflow, else come out and return the topmost element, the topmost data that we have. So return top data. If we check here for the peak, so the top element is %d, whatever it returns here. Then we have the print method. So for print again we have to check if it is not empty, and then we need a temp variable to traverse through the entire list that we have. So here temp is equal to top, and then just give instruction that the elements in the stack are. So now till what time do we have to traverse through the entire linked list? Till the time we don't get the null value. So here we don't know how many iterations are required, so we are taking a while loop here, and inside the while loop we have to write here as till the time temp is not equal to null. So till the time, every time printf whatever the value we have in temp.data, as it is starting from the top variable. So first it will be printing the top, and at the last it will be printing the bottommost element. So %d temp data, and every time move the temp to the next node. So here we have temp equal to temp arrow next, and that's it. This is how we can implement stack using linked list. So this is all about the program. Here first we have the declared methods, all the 5 methods. Then here we have the definition for the structure. Then here we have the main. Everything inside the main will be in the while loop. Just we have this integer data and choice variables. Everything is inside this while loop here to take the choice of input from the user. Then after that we have the switch case depending upon the choice entered by the user. Case 1, case 2, case 3 and case 4, and by default it is going to return 0. It means it is going to exit out of the program. Then here we have the push function. After that we have the print function here. Then we have pop, is empty and pick. This is all about all the functions. So now let's execute the program and see how it works. First we have to give the choice for pushing the element. So let's enter the element here as 9, then another element, let's say 45, another element 3, one more element 78, another element, let's say 0, the last element, let's enter here 54. We can add as many elements as we want. Now we have all these elements. If we just check from the top to the bottom, so first we have 54, 0, 78, 3, 45 and 9. Now if I give the input as 4 to print all the elements of the stack, so we have it in the same order: 54, 0, 78, 3, 45 and 9 from top to bottom. This was the first element that was entered, and this is the last element that was entered. If I want to pop out any value, so give the choices 2. So here it is giving me a statement as the deleted element is 54. If I delete it again, if I pop out the value again, so now the deleted element is 0 here. Let's add one more element, 23. Let's check the top element. So here the top element is 23 here. For the last time, let's print all the elements. So here we have 23, 78, 345 and 9. So this is all about the linked list implementation of stack. If you have any doubts, you can give us a comment in the comment section so that we can get back to you. If you have any doubts, we will surely get back to you with the appropriate solutions. And please like our video, which because this gives us the motivation to make new videos every time. And please don't forget to subscribe to our channel, and please press the bell icon so that you get a notification whenever we upload a new video. Thank you very much. Have a good day.